I'm gonna say from science.
That's actually surprisingly a good amount.
All right, y'all good over there, goofy people? Maybe not. Okay, so that's still making noise. Turn it down.
Dirt and the peanut butter. Hey, you just get crazy.
Okay, I've got your attention. Just be sure that you turn in your glass vials, because like I said, those are expensive and I don't want to lose them.
I did it.
Cool deal.
Turn in our what?
The glass vials. Yeah, I know. It's down as low. Oh, I don't know.
With you.
It's muted too. So it's just... Ah, we good? Sometimes they... I know. All right, Ethan, Michael, we good? Cole, hurry up. All right, so here's what we're gonna do. We are gonna go over again, kind of what we went over just a bit ago. Alex, there is an activity with marshmallows that I will make sure that you get. I'll post it. We all just did it. It's balancing equations with marshmallows. So, and I give you guys lots of opportunities to balance some more ones today. So Michael, we did a, he says, we did a review we're doing a review today of physical and chemical changes, right? So what do we have here?
Ice.
That's ice.
Melted.
And it's melting. So what is that?
Physical.
That's a physical change, right? I've got to see if I can make this be quiet because it's going to make me nuts. I really think it should just. If I just had a headphone stick in it, it would be quiet. But I don't think I have one.
Can't you just turn the volume?
It's all the way down. It will go down lower than that because Zoom won't let you turn it off. It'll let you turn it to the lowest. So it's at low. I don't know.
Can't you just mute Zoom?
No, because then she can't hear me, us here.
There's a little mute button.
No,
Yeah,
that mutes
that's
other
mutes
people.
you. Hey, Cole,
That mutes you now.
you got a set of headphones with a plug in them?
With the Apple plug, yeah.
Yeah, just,
Never mind.
do you have any headphones?
Just-
Actually, I do, yeah.
Just literally plug in the headphones.
Yes, I do, that's all you
need.
got?
Just regular headphones I can plug into that with a jack.
Sure, yeah.
I don't know why it's doing that today. Okay, so that's your physical. And then what's this?
That looks like sodium and water.
Close. Sodium does something similar in water, but based on the color, what would you guess this is? Do you remember our flame test? What color? What made that color?
Bromine?
No.
Potassium made that color. Remember? There we go. So that's a chemical change. That's gonna make me crazy. Yeah, yeah, on the other side. Thank you. I don't know why that's so annoying. Okay. Thank you.
Hang it on the little.
Just, yeah, hanging on the armrest. There we are. All right, so describing chemical changes. Now, your book mentions different types of chemical reactions. There are more than your book lists, so just know that. So if we start talking about chemical reactions, we're going to define that as a couple different ways. We're going to define it as a process that involves rearrangement of the molecular or ionic structure of a substance as opposed to a change in form or a nuclear reaction. We're going to rule that one out. That's different. Okay. And we're also going to say it's a process in which one or more substances, also called reactants, are converted into one or more different substances known as what? Reactants become products, right? And just like you'd read it, it's left to right. And the process that leads to a chemical transformation, one set of chemical substances to another. So these are different ways to define chemical reactions. But the main thing to remember is that the substance itself is fundamentally changed as opposed to a physical change where the substance itself is not fundamentally changed, right?
Yeah.
That's easy. So signs of chemical reactions. You can get formation of a new substance. So for example, what would this be? What might this represent if you were talking about?
Bunch of test tubes with paint and water.
Right. So yeah, it is that, but it's color change. So if you get a color change, it's a chemical reaction. If you cut an apple open and leave it on your cutting board, what's going to happen to it?
Brown.
It's going to turn brown. Why?
Bugs will get it.
Bugs will get it.
Well, that too, but the oxygen's going.
That's true. Yeah. Yep, it's oxidizing. Same thing with your bananas and whatever else. So yes, color change denotes a chemical reaction. Sometimes the color change is really obvious. Sometimes it's not so obvious. Last week, I had the younger class. We were outside for a couple of things. We did a demonstration where they had 2 cups of blue liquid and 2 different kids with straws, and they blew into the cups. One of them was just water with dye and it stayed blue. And the other was water with an acid indicator in it that turns yellow in the presence of acid. When you blow into the water long enough, the carbon dioxide that you're blowing out turns into carbonic acid, and then you get a color change. So one of them blew forever and it never changed, and the other blew and it changed color right before their eyes, which was pretty cool. So anytime you see a color change, it's a chemical reaction. How about that?
Ooh,
Why do your shoes smell?
Because there's colors being emitted.
Yeah, it's production of an odor, and that is because there is a chemical reaction going on. You yourself And your shoes themselves do not stink. It's the bacteria that live on your feet eating away at all the nice, wet, and gross stuff that you've left in your shoes. And they're, yes, burping and basically tooting out all the lovely gases that stink. Yeah. Mhm. Just like yeast. Yeast has a weird smell, right? You ever smelled like straight up dry yeast? Yeah. Or ever been to like a pizza place where they have?
Yeah, I make bread and when it like ferments for like an hour and a half.
Yeah, it's a weird smell. And that's because the yeast themselves are a fungus. They're a living organism and they're digesting, and the chemical reactions that are going on within their little digestion process is producing gas that has a scent. It's the same way you produce gas that has a scent. Same thing. So, and we all do. Yes, Jack.
I've been to a bakery where they actually like had this huge mixer and they put in the yeast and like
Yeah.
sourdough.
Mm-hmm.
And on the side it said 41 days or without adding too much yeast. Thanks, Jennifer.
Thanks, Jennifer.
It's like, oh, so great.
Yeah, that would make a mess, I'm sure. So my grandfather was a submarine captain in World War II. And one of his favorite war stories wasn't really a war story, but they made bread on the sub from scratch. And they made bread one day down in the galley and they put yeast in it and it didn't rise. And they were like, oh, the yeast must be no good. And they put more yeast in it. Well, they were submerged. And when they surfaced, the bread went, got huge. So he told that story for years as one of the funniest things that ever happened when he was in a war, which isn't fun, but that was fun, right? So yeah, that's gas pressure laws, which we talked about a lot last year. A highlight of a terrible situation. Yeah, he had a lot of interesting stories. So what might this one be?
That was like a rock solid.
What?
So this is the formation of a precipitate. So basically when you put something, usually it's a solution, you drop one solution into another solution. And this is exactly what happened today, actually. When you mixed your when you mixed your lime water with your carbonated water, it actually caused solids to form, solid carbon, which is why your water looked cloudy all of a sudden. So those solids are a precipitate. And a precipitate will often look like this, like a cloudy mixture within of your solution, but it will settle out eventually. And then what about this one? This one's fun. Evolution of a gas. So you mix baking soda and vinegar together and you get,
Carbon dioxide.
yep, you get lots of bubbles. Yep, coming out carbon dioxide. So anytime you see a gas being produced, that is definitely going to signify that you have yourself a chemical reaction process. Now, some other ones in here, these are the ones that show changes in energy, okay? So the others we're talking about like changes in appearance or state. This one is more about changes in energy.
Oh, so when you heat up water and it dissolves, that's a chemical reaction?
No. Oh, did I say state? I didn't mean state. What did I say?
You said when you turn something into a gas.
Oh, okay. No, evolution of a gas. So this is formation of a new substance. That's the word I was trying to find. It's an S word. My brain's dying today. But evolution of a gas would mean not a change of state, but the production of a gas because of the combination of chemicals in a different way. So changes in energy, you would have, for example, a change in temperature, right? So could get hotter, could get colder. Sometimes it's not discernible to you. Like you can touch it and you can't feel it. It's so small and so slight that you don't notice it, but it is there. Another one would be what? What's this one? It's almost Halloween. Yeah, I've got a glow sticks out. Production of light. So y'all are nuts.
I was like, totally.
So fun. So yeah, production of light. You know, when you break your glow sticks, they make that nice cracking sound the whole way down. You're cracking open all the little, they basically have little compartments in them that have different chemicals. And when the chemicals mix, you get light. They used to be, and some of the big ones still are, you know, the big ones, there's like one tube inside of the tube and you crack it and then the whole thing will glow.
Oh yeah.
Yeah, and those are a little different than like the bracelets that make all the little cracks. So yeah. I don't remember doing that.
No, you did.
I didn't. Yeah, blame your dad for that. I don't know about that. I'm gonna blame your dad for that one. I don't know what that is. So yes, production of light.
We have those like
Yeah. So this one produces light, but what else? What else do you get with fireworks? There you go. Kai's got it. Production of
My
sound.
favorite holiday. Everything that has to do with fireworks.
You love fireworks?
4th of July is my favorite holiday.
Oh,
I
do you?
had fireworks this year.
That
was
is
fun.
great. I like
And
fireworks.
broke my arm doing it because I lit one and started going backwards.
So yeah, like in the 70s, people weren't as careful. And my uncle and his friend used to set off those little firecrackers, like the little M80 ones, all the time just for fun.
Yeah.
And my uncle's friend thought he had a dud that he picked up that wasn't a dud, and it blew his hand up. So be careful, huh? No, it was Pete's friend. Yeah. So they just, sometimes you light them and they don't go. So he thought it was a dud, and they were cleaning them up off the yard, and touching it was all it took, I guess. So no, it totally, like, even for the rest of his life, jacked up. So yeah. So always be careful if you are playing with those, because they are dangerous. But it didn't stop them from playing with them as adults, because they still did.
It's so fun.
They did it every year when I was a kid. It was just their fun thing to do. All right, and then lastly, you got your absorption or release of electrical energy, right? So that's, y'all okay over there? So your absorption or release of electrical energy is another sign that a chemical change has taken place. So you've got your reactants, right? And your reactants are going to be located where? In your equation. Where are you seeing them?
On the left.
On the left side. So they are the substance that takes part and undergoes the change in the chemical reaction. And yes, they are going to be located to the left of the arrow in a written equation, always to the left, just like how you read. And you would read it like this reactant plus this reactant yields this product, right? And then your products are going to be on the opposite side of the arrow. And they are the substance that is formed as a result of the chemical reaction. Now there are some types of reactions. Okay, there are some types of reactions that always produce the same types of products. When we get to acid-base reactions, you'll find that they produce a gas, water, and a salt. Like every time, that's just what happens. And sometimes it's, sometimes it's more similar, and sometimes it's different. But it's always going to be gas, water, salt. Like it's what goes with it. Okay, yeah. And they're always located to the right in a written equation. These reactants yield these products. So equations. This is what we've been working on, and we're going to just pound it, because these are, I'm going to make sure you get it. This is something to know how to do. There's some things that, you should be aware of and kind of move on from them. Like, I know that it happened, but I know that this is a thing, but I'm not going to major in this subject. This is something you should know how to do, whether you're majoring in it or not, simply because it'll probably come up again in college, and because also this is the kind of thinking that you use in algebra. So this is where people say, why do I need algebra? I'm never going to do algebra in my life. You do algebraic thinking a lot, even if you don't do algebra. And this is algebraic thinking. Yes, Alex?
I think I found a part going physical states.
Oh, you did. That puts you at 25, doesn't it?
We're definitely at 25.
I think you are. I'll have to double check. So equations can show physical states.
19 of them.
I'm gonna fix it before I forget it. It's hard because if these are in all caps, like some of these fonts are in all caps, and they don't always show you spelling errors, which is fine. So yes, state of matter, whether you have a solid, liquid, or gas, is listed in parentheses to the right of whatever molecule you're dealing with, okay? Yes.
So,
She's giggling her head off. What?
because I'm like answering questions and I'm completely wrong for all of them. So I don't, wait, what's the order?
Come on, you got this. Come on.
You can do it.
So the 4 states of matter, I only see 3 up there, and I yelled
Right.
at one of them. And
Right.
there you go.
So-
Did I think-
Plasma's not up here because we're not dealing with it so much in
Got
this
it.
situation. But yes. Was that all you were asking or what?
That's it. I was wondering.
Okay. We don't need to worry about plasma tomorrow. Yeah. We will. All right, so if you see an AQ, listen, hey, if you see an AQ, it means it's aqueous, which is more than just saying it's liquid. It's saying specifically that it's in a water solution. And you'll see that very frequently when we start working with solutions in particular, which is like a whole unit or a whole chapter or two. But AQ means that it is in a water solution, which makes, what do we call water? What would we call the water in a water solution? You got 2 parts in a solution.
The solvent.
Solvent. And what do you call the chemical that's dissolved in the water?
Solute.
Very good. Solute and solvent. All right. And then the arrow is always read as yields or produces. So you can say it either way. And then this, if you see it, means it's reversible. And there are some reactions where you're going to see that. And then sometimes you'll see something like this, where it'll say heat, or remember what the symbol is?
Delta.
Delta, right. And it means change in temperature. Remember the Delta airplane? Think of the logo. What's it look like? Oh yeah, just like that, right? It's a triangle. So delta means change or change in temperature. And sometimes you'll see other things there written too. Like in this case, it says catalyst. And sometimes there'll be the name of a catalyst or the formula of a catalyst written there. Sometimes you'll also see sometimes people will just randomly write the word energy, or energy in the form of sunlight, or like you'll see that in particular with photosynthesis, they'll put like energy in the form of sunlight over top of the arrow. That's not an uncommon thing to see. So how do we balance? So we were doing this, so here's more of it. We have to remember that we're conserving mass, we're rearranging atoms, and that they're always going to be balanced on both sides. And so subscripts, if you remember, are the guys at the bottom, and y'all okay over there? They indicate the number of atoms or elements in a molecule in a formula. So like Michael, when you were asking why I do them in 2 columns, that's why I do them in 2 columns. Because for example, if you have the same element in 2 molecules in the reactants, if you are changing one of the molecules but not the other, and sometimes it can get confusing. I prefer to keep them separate as long as I can. Just because like with my experience with the big organic molecules, it can get crazy. And then you get your coefficients, and your coefficients are the bigger numbers in the front, and they're obviously showing it's a relative amount of each substance present. So how many of this molecule, how many of this molecule, right?
It was really easy until we started adding both of them together, and then we had to do the entire thing.
Yeah. And then when we start doing, like next week, we're doing net ionic equations, and that's might be a little more challenging. I really think that most of this kind of basic inorganic chemistry, it's a little challenging, but the organic stuff is like a whole new level. That I would say that was the only class in college where I thought I just, I thought I did worse than I did. Like it was one of those where I left the class and I was like, I just bombed it, and I didn't. I got like a B. But I thought I had like wrecked that class.
It's the best feeling when you thought you failed and you actually get a good grade. And
Yeah.
The feeling after that, you're like, I'm literally the best.
Well, what's funny is like I had that feeling though for years though, Ethan. Like I looked at my transcripts 3 or 4 years ago. I found them in the safe, and I was like, I gotta be in that class. Like I still to this day feel like that class killed me, and it really. Probably because it was maybe the only professor I had who wasn't like warm and friendly and amazing. Like all the Hollins professors are awesome. And she was really kind of stiff and not so warm and friendly, and constantly confused me with my friend, which was not normal. So it was weird. So when you see your parenthesis, okay, so the parentheses go around polyatomic ions that can be grouped together. So for example, right there, you got a hydroxide there, and they're grouped together. And it's just letting you know that y'all, come on. Those are grouped together. And so how to balance them. So here are steps again. We'll review again. And this is all going to be online. So if you need to go back and practice, go back and practice. So here we have same thing as before. Draw your little cross at the beginning, right? And here's the thing. I know people like when they're doing math and stuff, if they know what's coming, they like to just skip a step and just move on. I'm one of those people that doesn't like to skip. I want to write all the steps because if I get to the end and something doesn't add up, I want to go back and find the problem rather than go back to the whole beginning. So,
Make a mistake, I just do the entire problem. again.
see, I can't, so,
I just can't be bothered. to
I
write
just usually try not to make mistakes.
yeah, that's always a good way to go.
Oh, you got it right now.
So yeah,
I mean, it's not that hard.
when you have your reactants on one side and your products on the other, you can start moving through. All right, so in this case, like Michael was saying before, this is another way you can do it where I didn't do them as separate molecules, right? I did them exactly as your book was listing them. I like to do them as separate, which is what I was showing with the marshmallow thing. But as long as you get the amounts balanced, it really doesn't matter so much. But again, it's metals, non-metals, hydrogen and oxygen, which if you need a mnemonic is no. So no. All right, there you go. You got them written out. And I ate too many marshmallows. So remember that you can't change your subscripts, all right? But you can change your coefficients.
Can I make a request for next Tinker Day that you give them the donuts after class?
Yeah, yeah, we should do that.
Because it took me like straight up 15 minutes to like wrangle. Well,
But
first I
aren't they
caught it, the pile
fun?
of this.
I understand them, okay?
Yeah, but you were
So I
also
can
like,
handle them.
you were also the
I
problem.
don't-
You were the problem that helped the problem. which
I
is-
love it.
Two problems.
Well, they did say that there would be, they did say there would be a Tinker Day in the spring. So fingers crossed that that's real. But I haven't ruled out the fact that this whole rumor is just a rumor to throw us off, that there really will be Tinker Day either tomorrow or Thursday or Friday, 'cause then the month's out. But multiple people, because I fussed last week. I'm like, where is my Tinker Day? And all these girls were coming back and they're like, yeah, where's Tinker Day? And then a couple of them were like, oh no, they're not doing it. And everybody that didn't know that already was like, what? No, that can't happen. They used to, way back like 100 years ago, they had 2 Tinker Days, one in the fall, one in the spring. And then I guess they figured too much time out of class. They narrowed it down to one day. But what I want is I want a historian to go back and tell me what happened in, was it 1918, the influenza outbreak? I want to know, did those girls hike? Because here's the thing, those girls hiked that mountain in full length wool skirts and leather heeled shoes. Like there's a famous picture, it's in the book over there, that was like up, huge big print of it in the science building, of women in like 1890 something, hiking the mountain in like 1890s clothing, no athletic shoes, and one's pulling another one up the hill. And you're like, yeah, they're doing it. See, you can hike with a mask or social distance. Gosh darn it, it's not that hard. Look at those girls, they didn't care. Of course, these are the same girls that like put their curling irons in chafing dishes and did all kinds of crazy things. Chafing, you know, chafing dishes, when you have a like when you have a party, it's got the sterno under it, and they put their, like, they were like metal rods at the time, and they just stuck them in there so they got hot. Well, then when Prohibition came, they took away the alcohol, so there were no more alcohol burners to do sterno type things under the chafing dishes. So there were all these women who couldn't curl their hair and were ticked off. And actually, I have like a 1920 yearbook over there that I got on eBay, and there are all these pictures of the women in the chafing dish club who wanted their chafing dishes back so they could curl their hair.
During Prohibition, all the alcohol
Right.
had to be going to make illegal foods.
There you
not
go.
illegal alcohol.
So what do we do here? The first thing we notice is that we had 2 irons on one side, 1 iron on the other, and we need to make that 2. And so we're gonna make that 2 on this side. Now we look at our carbons. We got 1, we got 1. All right, that's good. And then over here, we look at our oxygens. We got 3, we got 2. Okay, now I told the younger group, if you hadn't caught this already, but I think most of you probably have, the easiest way to figure out what you're doing here is to look at how they multiply together. And you're gonna, whoop, careful.
She stepped over it.
3 and 2, we're gonna give you 6 when multiplied, right? So if you multiply 3 times 2 and 2 times 3, you're gonna end up with the same numbers. So that's kind of where you should be aiming most of the time. So you take your 2 off, times 3 gives you 6. There's your times 3. Now you have 6, right? Then over here, do the same thing. It's times 2, it's gonna give you 6. Now you put your 2. But now you gotta go back to the beginning, right? Always have to go back. Once, sometimes twice. So when you go back to the beginning and you look at your iron, you're like, I have 2. Oops, no, I don't have 2. How many do I have? How many do I have? 4, right? So, okay, now I gotta look over here.
4.
Do I have 4? No, I don't have 4 over here. I only had 2, so how do I get 4? I gotta change that, right?
She changes the stuff below before she changes the stuff on top.
Did you follow it or no?
Yeah.
I can do it again. Do you want to see it again?
We just changed the stuff on
Yeah,
top.
Tyler wants to see it again.
You changed the stuff on top first?
Yeah.
Okay, so watch. Okay, there. Okay. First thing we notice, start with the metals. We have 2 iron, right?
Okay.
2 iron, 1 iron. Okay, we need this to be 2. So we have to put the 2 up here because we can't make it a subscript. It has to be a coefficient,
Okay.
right? So now we have 2 iron and 2 iron. Okay, we're happy with that. So now we look at our carbon, 1 and 1, 1 carbon, 1 carbon. We happy? We're happy. Let's look at the oxygens. 3 right here and 2. Not happy, not balanced. So if you look at what they multiply, if you multiply them by each other, you're always going to end up with the same amount, right? So we multiply 2 by 3, which is going to give us 6 oxygen. So in order to do that, we have to put the 3 right here in front of the molecule that contains the oxygen,
Right.
which is, now we've changed the carbon, but we're not looking at that yet. We're going to finish this step first.
Okay.
Come back over here. We got to go by the 2, right? Because we did 3 on one side, 2 on the other, kind of like fractions. So where we got to put the 2, we got to put the 2 outside the molecule that contains the oxygen.
Oh.
Okay, there. Now we go back to the beginning because we see we have 6, 6. Okay, we're good. Now we have iron is 2. Nope, it's not 2 anymore, is it? Because we changed it. So now it's what? It's 4.
Right.
So he's back to the beginning and it's 4. So now that one's 4. This one has to be 4
Right.
and it's 2. So we need to make it into 4 and we have to change the 2 to a 4. So always work with pencil.
Okay.
Now we look at the carbon, 1 carbon. Uh-oh, now we got a problem here. We have 1 carbon here, but we have 3 on this side. So how do we fix that? We got to put 3 over here. And that goes right in front.
Okay.
Okay, back down here at the bottom again. Now we're checking our oxygen. It says we have 6. Do we? 2 times 3 is 6. Okay. And says we have 6. 3 times 2 is 6. So we got that and we got that.
I do get it now.
Now we got it. We're balanced.
I think we should do it one more time.
Oh, we will. So there's where we end up. You guys are crazy.
Hey, maybe you could explain it like Miss Danny did an hour ago. I would have understood it.
I'm just saying, ooh, blue on a freaking.
Do you want to do it one more time, Shannon? Did you need a pencil?
I have one right here.
Okay, one more
I
time.
just don't believe I get it and I want to get it.
Nope, you should definitely get it. Okay, so you write them down. Start with your metals, then go to your non-metals, then go to your hydrogen and your oxygen. Okay, give her a chance to write that down. Where is my child?
Your child's gone. He done
Gone,
disappeared.
reduced down.
Mm-hmm. I see that. All right, so
I didn't write no space.
no, you're fine. Take your time. All right, so you look and you say, we have 2 irons on this side. We only have 1 iron on this side. We need them to be the same. So we have to change this 1 to a 2. And then we have to put that in front of whatever molecule contains the iron. And in this case, it's just by itself. So we look at that and we go 2 right here, Fe2 and 2 Fe. We're good, squared. We're squared away. Now we come down here, 1 carbon, 1 carbon. All right, we're good. Now you go to the bottom. Last one is oxygen, 3 oxygen, 2 oxygen. If you multiply them by each other, you'll definitely get the same amount on each side. So if you look at this one too, and you do that by 3, you're going to get 6 oxygen on this side. So in order to multiply it by 3, we put it as a coefficient in front. And now you have 3 pairs of oxygen.
Carbon.
Yep, we'll get to that one in a minute. We come back over here to this side and we multiply that one by 2 to get 6. Then we put 2 in front of the molecule that contains the oxygen right there. Then when you do that, you got 6 and 6, but you always have to go back to the beginning because chances are you changed something. So you go back to the beginning and you look at the iron again and we go, how many iron do we have? We no longer have 2, we have 4. So this becomes a 4. All right, now we need to look what's over here. We don't have 4, we have 2. And we have 2 written here, so we just need to change that to 4, and then we come back up to the molecule that contains the iron and make the coefficient 4. So we have to take away the 2. And we look at the carbon, we have 1. And carbon here we have 3 CO2. So we have to change that to a 3. And then change the other side to a 3 and put the 3 as a coefficient in front of the molecule that contains carbon. Yeah, we're gonna do more, don't worry. And then you look and you go, and I have 6 and 6, and I'm good. So here's a helpful thing to do. We were doing them earlier with lots of different ones, but this website, we're gonna go to this website in a minute. And this website is fun to start with. If you're having trouble, it's a good place to start because what it does is it shows you the equation and it puts a little drop-down menu.
It was easier.
Yeah, it's a good place to start. It puts a little drop-down menu where you need to add a coefficient. So it's like, focus here, this is where the problem is.
The advanced one gives you a drop down on all of them.
Yeah, it gets trickier
Is
then.
that a J or an I? In front of
It's a J, but
It's
it'll
a
be,
J, but on the paper it said an I, so that's when I typed it in the first time, because I couldn't find the link. It went to this book website.
Wait, on the
about-
paper it's an I?
that's weird because when,
I've
because
got
I
it.
clicked it on the actual, maybe it printed oddly because I clicked it on the actual copy, like the digital copy, and it went right to it.
I put in that and I got a 404, but with the Education J Lab.
Yeah, that's what you did, but I clicked the same link that's on the digital copy and it went right through.
That was in the
I
email.
just-
So we had
Yeah.
three different
Education
ways to
J
put it in, and 2 of them.
I then they had to write the entire thing out.
So here's for your,
And I accidentally clicked off of it once, so I had to write. the
these are your
entire thing
notes.
again.
I was gonna go over these with you real quick before we go to that site and practice for a bit. So does anybody have their answer for number
I do.
1?
Mass
Okay.
cannot be destroyed.
Right, mass can't be created or destroyed within a closed system. Now, oh, I didn't know they were all gonna go. They did. So, that's cool. Remember that, law of conservation of mass is going to be applicable across the board, but you have to keep in mind closed versus open systems. The juniors book focused more on that, but basically if you have a closed system, like think of it this way. You have a bottle of Coca-Cola, all right? Caps on, brand new bottle of Coca-Cola. You put it on an extra sensitive, put it on an extra sensitive instrument so that you can get an exact mass, like multiple digits, let's say like 10 digits, okay, past your decimal, super exact number. Okay, then you take the top off of it, you leave it for a day, you put the top back on it, and you put it back on your balance or mass or whatever instrument you're using. Will you have the same or a different measurement? What do you think?
Probably different
Why do you think it would be different?
because they compress as much air as possible into the bottle, and when you open it up, you allow it to aerate and put only.
Right.
Which is
When you open the bottle of Coke, what happens?
you let air.
It fizzes, right? It bubbles. So basically you've got carbon dioxide dissolved in the liquid, okay? And it's under a certain constant pressure. And it's in a closed system because the lid's on it. But when you open the lid and you relieve the pressure, now you have an open system. It can access the environment. So all the carbon dioxide that is dissolved in that liquid in the Coke now turns into gas and disappears off into the air, and you don't even see it go. But it does have mass. It's a tiny bit of mass, but it has mass. So if you, yeah, all right. So it does have mass. So yes, it would be different. It would be a teensy bit different, but it would be different. So using the law of conservation of mass, explain why the following reaction is wrong. And that was pretty obvious because
There was no oxygen or hydrogen.
Yep.
in the HCl.
they disappear in this equation here, which means that they're not conserved. So it can't be an accurate equation.
That's what I said.
Say what? I didn't hear you.
It's like gone, reduced to atoms.
Gone, reduced to atoms. So not gone. All right. How can you tell when an equation is balanced? And that's what we were discussing. Both sides contain an equal number of atoms. That's what was good about the marshmallows. We could count them. right? And once we counted them, you can really see it with your eyes. So yes.
Stan should be in a jazz band. He was really good at sounding.
Jeez. So the 3 in 3FE is a subscript, is a coefficient, and then the 2 in H2O is a subscript. That's easy, right? You guys, who in here has not done algebra? Anybody not done algebra? Everybody's done algebra. So you guys know coefficients.
Yeah.
And yep, they're pretty easy.
Hate it.
Yeah, and then you got subscripts are pretty easy to understand.
Jack has not done algebra.
You haven't done algebra? That's okay if you haven't done algebra. It's fine. We're homeschoolers. That's what's great. You can do college level science and 8th grade math if that's what works for you. That'd be what I would be doing. So, it totally works. Whatever works. Are you guys okay? Hey, Cole, you want to share what y'all talking about?
He's such an algebra.
That's not what I said. No. I told you I said I find it mildly annoying when there's letters in the equation, but it happens every week when I do math, so it's hard to get used to it. And it's hard to-
So coefficients.
Yeah, quite the gossip we got.
Show it. Coefficients change the amount, and that's important to remember, whereas subscripts change the structural identity. So think about that. Subscripts are gonna, Alex, you okay over there? Subscripts are gonna change the structural identity because that is essentially the molecule itself, right? Are we with it?
Yes.
So if I said C6H12O6, that's a sugar.
Sure.
All right, so C6H12O6, I could put a 2, a 3, a 4, however many in front of it. I still have that particular molecule of sugar, right? But if I change the 6 to a different number or the O to a different number, now I have a different substance entirely, right? So subscripts are going to change the identity of the substance. And then why is the Fe balanced as 3Fe instead of Fe3?
Because you're not allowed to change the subscript of something that you're balancing.
Right.
That would change it into a different molecule.
Changes the identity of the substance. So that's why when we're balancing, it goes in front. Still the same number of atoms for the sake of balancing, but a different substance. Okay, so let's go to this website and let's give a couple of these
Are you doing an advanced one?
a try. Well, let's start with a couple of easier ones. So let's start with some beginner. We'll do 5 beginner and then we'll move on.
For my homework, instead of being a beginner, I accidentally did the intermediate.
So here's what, if you haven't looked at this yet, so if y'all good? If you haven't looked at this yet, the cool thing, oh, hang on, what's up with my screen sharing? 1 second. The cool thing about it is that it gives you a hint, like right here is where you're supposed to be messing around, which is nice, right? So we have H3PO4 plus 3NaOH. All right, so,
No. That's annoying.
huh?
No.
What? I didn't hear you.
There's 7 oxygen on the.
Yeah, so if we were to,
Oh my God.
I'm hoping that people
hang on, I'm trying to split it, screen it. 1 second. Uh-oh.
You okay?
Put this here so I can see it. Trying to make it a little bit bigger. There we are. Now I'm trying to scooch this over a bit.
What do you mean by it's okay?
1 second.
Sure. At least I'm so okay because she felt like.
So, what in the world are you guys doing over there?
Weird.
See if it let me draw like normal, because it was being weird earlier when I was trying to draw, right? Okay, there we go. So here is our formula. Oh my, our equation. Where'd it go? Come back. So we have H3PO4. H3. Oh my gosh, hold on. This thing is going to be dumb again. It doesn't want me to do this. Okay, fine, don't do that. Jeez Louise. Never mind.
all the donuts and marshmallows. That's all right. She's
It's gonna be weird. I know. I don't know why it's doing that. All right, it's okay. We'll just go back over here. Somebody else use paper, okay? Because it's not gonna let me write nicely. I don't know why. So here's what we need. H3PO4 plus 3 NaOH. Tell me what it is we need to do. Especially if this has been a challenge to you, you should be writing this out and giving it a shot. What am I not gonna do?
This one's so easy.
This one's so easy. Okay, what is it?
2.
2. All right.
Why did you say 2? Because there's 7 oxygen. I tried to say 2. Yes, you did.
Want to try again?
So there's 7 oxygen. I don't think 7 would work.
Is it 3?
There's 6 hydrogen and 7 oxygen. Oh, that's in 3.
Good job, Ethan. Ethan's got a 3. All right, excellent. So if you've got paper in front of you, you should 3 oxygen. They're right here.
Yeah, but
And
what about
then-
the other 4 oxygen?
So, but they're here. Here's 4 and here's 4. All right, so next one, you should have paper out, especially if you think you need practice.
And this
Okay. 2 aluminum, 1 aluminum.
Yeah, it's 2.
Yeah, it's 2.
It's 2.
Yeah.
Does everybody agree?
8.
Okay,
Yeah.
very good. All right, everybody write this one. If you've got stuff to write, write this one down.
PCI 3?
CL, that's an L.
I know.
That's an L?
It's a
Yeah,
computer part.
it's
a
chlorine.
PCI 4.
Yeah,
That's the only thing to support the PCI 4.
I'm pretty sure it's already balanced.
Yeah, it's balanced.
Is it?
Yeah, I think it's just 1. I'm like,
give everybody a chance to look.
Is there? Oh yeah, because there's hydrogen. Wait.
It's either 1 or 4. It's either 1 or 3.
Those are really different
Oh,
answers.
yeah.
1 or 4.
It's 1.
It's 1.
Hang on, giving people a chance to catch up.
I guess it's just. Yes. Why would he want though? Miss Danny.
I would agree that I think it's.
That's what I know.
I think.
I got the word.
Everybody agrees we're 1? Balanced. There you go. All right. What do we need here?
Wait. Sorry.
Calcium carbonate.
Balance.
You think what? Oh, really? That's random. You think this one's balanced too? Hang on, she's looking. Shannon's looking.
It's not balanced. Wait.
It's not balanced. I know that.
Yes, it is.
C, C, CA, CA, O3,
Hold on.
O2 plus an O here, and we're balanced.
It's balanced.
Excellent. All right, how about there? Strontium and water.
I'm seeing a lot of 2s.
You're not balanced.
It's not balanced.
You need,
2 O's, the 2 oxygens, and almost.
okay, I know what you mean.
I'm like, it's 2.
Yeah, it's 2.
It's a 2.
No, it's not. It's not because there's an H on the other side, so it's.
It's 2 H2 on one side, there's an OH2. So it should only be 1, that's balanced.
It's balanced. Yeah.
It's a trick question, isn't it?
Yeah, all of them are.
There you go.
Not all of them.
I
a lot
told
of
you
them.
guys it's already balanced.
So go to intermediate.
Good dance.
We'll do a couple intermediate and then we'll do some advanced. Let's do
Okay.
2 of these and we'll do 2 advanced.
Oh, advanced, okay.
Now these are intermediate.
It's advanced.
So the CO needs at least 2. I agree with that statement, Michael. I-
2 carbons,
I think
6
the APR needs to
oxygen,
also too, because HBr.
4,
No, wait, no, I don't think that needs to be. I don't think the HBr needs to be.
3 H's, that's 3, 1, 1, 6 oxygen,
Actually, she was the worst.
2, 3.
Wait, no, I don't think HBr.
Can't do any subscripts, only coefficients.
You need 2, 4, and 2.
2 HBr.
2, 4, and 2, Alex says. What's anybody else say?
Nah, I don't think. I,
I feel like
Yeah, I think it's-
counting an option, but I also.
I haven't written it down, but I'm pretty sure it's 1, 2, 1.
Yeah, I think Michael's right. I agree with Michael. Yeah.
1, 2, 1, or would you say
That's my
2,
guess.
4, or something?
1, 2, 1 is my first guess. Yeah,
One,
okay.
two,
So it's,
yeah,
what is yours?
1, 2, 1.
I think it's 2, 4,
1.
and 2.
2, 4, 2.
2, let's check 1, 2, 1 first.
I didn't write it
1,
down, so-
2, 1, right?
Yeah.
And you said 2,
What did you say, Alan?
4.
4 and 2.
Oops, I can't see the 4. Hold on, jeez. Come here, 2, 4, 2. Up, hold on, can't see that either. I can't see that 2. This is fun. 2, 4, 2. There we go. Let's see.
Nice.
Boom, nice job. All right, let's do 2 advanced. Oopsie. Up, up. No. Go that way, go that way, go that way. Go backwards, go backwards, go backwards. There we go. All right, have fun. Let's
This
see.
one I'm gonna write down.
All right.
And then that's three.
NaNO3, H2SO4, NaHSO4, and HNO3.
2. 2. S. I think the first one needs 2.
First one needs 2.
Okay, it's already balanced.
It's already balanced.
Is it?
Well, I watched a little clips on Facebook of it going on, like I know I don't have this, my mom does.
Hang on, I'm bringing it right back. I'm just getting rid of that. Maybe it'll let me eject at some point.
You already got I'm sorry.
No, what does it mean?
That's the scientific
It is closed.
And
Okay.
unfortunately,
Alex, it's strange. You act like me when I have too much sugar. Like you're acting like me right now. It's like,
I always have had too much sugar. I'm always acting like this.
Are you all right there, man?
No, he's having, he's not all right, like, you should, already such a strong.
Jeez.
Are your eyes open?
Now we know.
Your heart functioning, are you alive? That's a better. Really, it's not just.
are you alive?
He's just kind of barely
I
alive,
think
I
he was
think.
riding a sugar high, and that's what he's alive. He rides a constant one.
No.
Anybody have an answer for it yet?
I'm still working on it.
Still working on it, okay.
Has to be down to the ground by the time we get it.
Okay, so please spell.
What are you doing?
I'm you disowned him. Trying to help my friends.
Trying to help him. Oh my gosh, maybe you should ixnay on the marshmallows, May. I think maybe you've reached your limit.
It's already balanced.
Yeah, okay. She's going with it's already balanced. Anybody else?
Balance.
There's sodium, we got a sodium, got 1 nitrogen here, got a nitrogen here. Oxygen, there's, let's see, we're not there yet. Sulfur, okay. 3 oxygen, 4 oxygen, that's 7, 4 oxygen, 3 oxygen. Oh, what do you know? Way to go, Kai.
Oh, guys, check it out.
I did that too.
Way to go, Shannon, you too.
You're over there in your brain.
All right, there you go. How about this one?
I knew it because of the.
So, okay, so, no.
Oh, Alex. Stop.
Okay, I have my answer.
You have your answer already, okay.
1, 2, and 2.
1, 2, and 2, okay.
I'm just writing it down.
He's very
Not
fast.
even trying to-
Is he guessing? Are you guessing?
I think he can like just see them. I don't know.
Yeah, I was able to do it without writing it down, but I wanted to do it for the.
Yeah, I need to write them down. Always.
Are you holding your breath like a shark?
Oh, good. That's good. That's what I want to check. That works.
On the marshmallow.
I know. Well, oh my gosh.
It's just the dye right now. It's just the dye, it's already soaked my fingers.
You're like stuttering now.
He's like, I so barely have words to stutter.
Is this typical Bailey?
Yeah, that's what it
You
is.
know, we don't
I
like
wanna
the
check.
thoughts that, there was an incident a few years ago. It's no big deal.
Yeah.
The hyperness, yes.
Hmm.
Yes.
Wow.
This isn't normal, I don't.
Well, I do that. I'm doing it right now. I always shake something. Some part of my body's always moving. I can't be still.
It's not a shaky knee.
114. Okay.
He's straight out of the other.
She says 114.
What?
I thought you were actually like Eminem.
Oh.
That too. Another one.
Funny.
Water will wash out.
That's like that's a total boss move right there. I can do that too.
No, I didn't bring the water bottle.
I think I know what it is.
All right. What do you have?
I think it's 1, 2, 2.
1, 2, 2, 1, 1, 4. You said what? 1, 2, 2?
1, 2, 2.
I said it right now.
Yeah, I think it's 1, 2, 2.
1, 2, 2. All right. Let's see.
Yeah.
Oh, wait a minute. I gotta take it off the annotate
And
thing.
that's currently at 1, 1, 1.
Let's see.
His voice weird.
1. You said 2 and 2.
Yeah,
All right.
yeah, that would give.
Boom. Nicely done, people.
Yes.
All right. Here's one. I'm gonna do this time. I'm gonna scooch it over here, and I'm gonna write on it. So for those of you who are trying to figure it out,
1, 2, 1.
Yeah, 1, 2, 1.
And I would never. ever-
1, 2, 1.
My legs
Yeah.
are tapping.
I agree with Michael. 1, 2, 1.
Yeah, but-
Who's still working on it then?
I'm as fuck.
So we got C O H. You do it that way too. I hate that this thing doesn't erase though. Like my thing erases typically. Two. Oh, come on.
Actually, that is pretty accurate. Except
Oh, God.
we're
I'm planning my
Still
own
doing.
stuff. I'm planning my own
arm.
stuff.
You wanna get, okay, I can do that right now. if you want to.
You know, if I wanted, I wish I wore a sweatshirt. So I could just like, I never see this, like.
So how many C's? We had 1 and 1. How many H's? 2.
1.
Then over here we have 1, and then we're gonna have 4 hydrogens, right? We take that out.
That's why I said one is.
We're saying 1. Ah, God, I hate that.
Yeah, add it to.
1, 2, 1. There you go.
Sugar, like,
Yeah, just,
like half a
yeah.
donut.
Okay. Oh gosh. All right. Yeah, you can do that while I try and fix that.
Oh, you're marshmallows too. Yeah, so you can say those.
Stupid thing. That's annoying. My stylus erases like a normal pen, but it doesn't do it in Zoom. It does it in every other program, but in Zoom, I turn it around and my eraser is a pen. This makes me crazy.
I know, I'm confused.
There.
What's up, man?
Miss Annie, where are your fidget toys?
Oh, I put them up because of virus pandemic.
COVID, man.
I know, it's taking everything away.
That's the one thing you take away from COVID is they took away your fitness things.
Took away the fidget things and made Kai mad.
That's what I'm doing. I'm doing this.
Yeah, I'm doing.
Twiddle my thumbs. You
Yeah.
think that's gonna be
I was just, I
faster?
actually did that.
It was late.
That's a diet out.
Oh, it's time to wait.
Out of the way.
Okay, I have it.
You have it already, huh?
Yes.
I don't understand. Great company going at like 5 million miles per hour. I was an hour.
One-
a mile.
No, it's
It's
17621.
I get to see Santa Claus just in time.
Going down.
You're on a sugar crash. I'm on the continuous sugar high.
I didn't go on.
Oh, she never remembers that.
I'm sorry. I didn't-
6,
I didn't have a
and 1,
I didn't eat any lunch.
6.
You just have sweet onion sauce on my son.
Whoop, why'd I do that? See, look at that.
Whose pencil is this?
I did it anyway. You're supposed to put it right there.
You just found it?
Yeah.
Either a
Unreal.
math problem or you
Unreal. Eat it.
You're stubborn or doing it.
Eat it. You I'm not gonna eat a pencil.
I guess my
Yeah,
question, right?
3 and 1.
That's what I thought. That's what I thought.
That's good.
That's what I thought.
Well, bet.
Page is 3.
It's a delicacy in our country.
There's 4.
I was sick. I think it's a good thing.
Jack, this is a delicacy in my country. Would you like to try?
Your country's like.
No, it's not.
What pencil are we talking? The Capital pencil or normal pencil?
Of course, that's a question.
Yeah.
So what do we have? Does anybody have anything yet?
17621.
No, we didn't do it.
Whoa.
1. You said
I am mentally checked out right
7,
Mentally, I'm still.
I'm
6,
Oh.
2, 1. That's what you're going with?
Yeah.
Snap me.
Yeah.
I did.
Daggone.
Oh.
You are fast in your head too.
I didn't say that.
Mathematical prodigy over here.
Your brain like, oh, there's the answer. And then there's me that's like there for 5 hours trying to figure out one problem.
Okay, so real quick, since we're wrapping up, hold on, I'm taking my screen share off and I'm taking it off of there too for a second. Okay, listen. Are you listening? Y'all good?
You know, I'm trying to.
I know you are, but there's a lot of distractions.
There's a lot of noise.
I want to make sure that you guys, are on track right now with stuff. So, if you checked the email last week, then you saw that you need to have, in order to get credit for last week's lab, you need to comment on the video because we didn't, right. Some of you did. I don't think everybody has yet because we didn't get our calculations completed in class, right? So I want to make sure that you saw it through to the end with the way it was supposed to work out. This is pretty much the last week to turn in anything from Q1. So if there's anything you're missing, if it's not in today, it's pretty much not going to get counted. I mean, you would know, I would think. I could look. Let's see. You're gonna have, so you guys have, so this chapter, we broke this chapter into a couple of chunks, right? So you don't have a test until your next test is on the 10th of November. You have a little break here with your tests because I really want you to practice your balancing and make sure you understand it and you get good at it and you're not rushed into it. Okay. So that test is on, that's the chapter 8 test, and it's on the 10th of November. So yes. Yeah, your mom just, it may have been the one, I know she emailed me about something, let me look. I know she sent me another one too, but I'm not sure if that's the one that, yeah. That's the one that she, I think that's the one that she emailed me. I'm not sure.
I have missing Marco lesson 9 class.
Do you still have it? I don't know if unless that's the one she emailed me this week, then I don't know that I have it. But if you find it for me, that's, just give it to me and I'll
Okay,
count
I
it.
have 2 missing work.
I'm
One of them
looking.
is a participation, and another is a lab you're supposed to bring in.
Hang on, I'm looking right now.
Is a lab you're supposed to keep.
So you have, hang on, I'm looking, Michael. I see you have a missing class participation for 9. That's when you weren't here.
Yeah.
So you need to comment on that video so I see that you watched it. And then what's the other thing you see?
Lab 9.
Oh, lab 9 was, wait a minute. I'm looking, hang on. Lab 9. So lab 9 was a complete or incomplete lab. It was, let's find out which one it was.
Yeah. I just on the class.
Hold on. I'm happy to look up anything for anybody right now if they're looking at for stuff or whatever. Lab 9 was the one about molecular properties of compounds. So it was the one with the sugar and the salt that we heated. Was that the day you weren't here? Okay, so yeah, just comment on both of those 2 videos and you're good.
Okay, can I do the same for like every lab?
Girl, you have a lot going way back. Let's see.
Good luck.
I know. Some of them are videos and some of them aren't. So
I did one of the labs at home. Like I remember doing it.
you just didn't send it?
I just forgot to send it, but
Okay.
I have it somewhere.
Okay, find that for me. And then let me do this. Let me go through and look at the ones that are videos that are able for you to make up, because some of them are just going to be really hard to make up at this point if there was data. But if there's videos, we'll talk about that. Does anybody else want me to look up anything for them?
I just turned in what I have missing.
You turned in what you have missing. Okay.
Give me extra credit.
Can I give you?
Like extra credit work. Like,
Oh, yes, sure. Would you like some?
I would take some extra credit
No,
work.
I
I want
need
extra
it.
credit work. I was
Okay.
relying on Tinker Day. And I'll use it.
I know this Tinker Day thing. Okay, so I'll do that then. I'll put out something to everybody since some people were really hoping for Tinker Day like me. And I'll say, if you want extra credit, here is a thing. And I'll come up with a thing, a good thing.
At this point, for all my business here, it's gonna be extra.
There's no lab.
You're gonna catch that.
videos.
There is for the, no, yeah, there was. I'll find it. Hang on. Maybe it did it not link. Let me see. I'll let Alex go and end this. Whoever else, Sydney. Hi, we're good. I think they already left.